Hello everyone. Welcome to the Gear series. Over the upcoming episodes, we will delve into a wealth of information about gears, from their fascinating history to the basics, exploring various terminology, and uncovering more details about how gears work. Have you ever wondered how things around your house work so accurately? Well, it might just be the magic of gears. Now, take a look at this classic mechanical wall clock. It keeps ticking away, telling time with precision. But how does it do that? Have you ever thought about how these clock hands move so accurately? Let's find out. The secret is gears. Just like in a clock, gears are these amazing little wheels with teeth that work together to make things move smoothly and precisely. But gears are not just for clocks. They're like the unsung heroes in many things we use every day. Let me show you. Look at this hand mixer. Can you guess what helps it work so smoothly? Gears work inside for that perfect mix. Now, let's shift gears and have some fun with toys. Look at this wind-up toy car. Can you guess what's driving the fun? That's right, gears. When you wind up this little car, gears inside start turning, bringing our toy to life. It's like a tiny gear-powered race car. Gears might seem like small components, but they play a big role in how many machines work. Gears also play a fundamental role in many machines, from simple applications like bicycles, to complex systems like automobiles and industrial machinery. In this video, we will kick things off by uncovering the brief history of gears and understanding the fundamental basics. We will also explore the terminology that surrounds these mechanical marvels. So, buckle up, stay connected with us as we embark on this exciting journey into the heart of gears and their intricate world. Now, let's learn the definition of gears. What are gears? Gears are special mechanical parts with teeth that fit together and rotate to transfer motion and power from one shaft to another shaft. Let's learn the major functions of gears. Number 1. To transmit motion. Here, the motion is transmitted from first gear to second gear. Number 2. To change the speed and torque. Here, the larger gear takes long time for one complete rotation, compared to the smaller gear. Number 3. To change the direction of rotation. Number 4. To change the motion from rotating to translating motion. Gear comes in different sizes. The size of the gears helps to control how fast or slow things move. Let's learn history of gears in short. The earliest examples of gears date from the 4th century BC in China, which have been preserved at the Luoyang Museum of Henan Province, China. The earliest preserved gears in Europe were found in the Antikythera mechanism, an example of a very early and intricate geared device designed to calculate astronomical positions. Its time of construction is now estimated between 150 and 100 BC. We will learn the complete gear history in separate episode. Now let's move on to gear terminology. Before that, if you are passionate about understanding the intricate workings of machines, exploring engineering concepts through animations, or seeking inspiration for your next mechanical project, you are in the right place. We also offer software tutorials for CAD laboratory designs, helping you master essential tools for engineering design and visualization. Don't miss out on our engineering puzzle videos, designed to challenge your problem-solving skills and spark your creativity. Our channel is your go-to destination for all things engineering. With over 100 engineering-related animation videos already uploaded, we have covered a wide array of topics, from the fundamental principles behind various machines to in-depth explanations of complex engineering subjects. Whether you are a seasoned engineering student or just starting your journey, there is something here for everyone. Make sure to subscribe to our channel and click the bell icon to receive notifications whenever we upload new videos. Now, let's learn the gear terminology. What is gear terminology? Gear terminology includes definitions used to describe gears and the terms needed to make them. Pitch circle. It is an imaginary circle passing through the center of the gear's teeth, where the teeth effectively mesh with other gears. Pitch circle diameter. The diameter of the pitch circle is called as pitch circle diameter. It is used to calculate gear ratios and design gears. It is indicated by symbol D. Pitch point. When the two gears are in meshing, the point where they make contact is called as pitch point. Circular pitch. The distance measured from a point of the teeth to the same point of next teeth measured along the pitch circle is called as circular pitch. Top land of the tooth. The flat, top surface of a gear tooth is called as top land of the tooth. It is like the roof of the tooth. Face of tooth. The surface of a gear tooth, facing outward above the pitch circle is called as the face of the tooth. Flank of the tooth. The side surface of the gear tooth, lying inside the pitch circle is called as the flank of the tooth. Face width. Face width is the distance from the front face of a tooth to the back face of the same tooth. It is indicated by symbol B. Tooth thickness. It is the width of a single gear tooth at the pitch circle. It is indicated by symbol S. Tooth space. The distance between adjacent teeth, measured on the pitch circle. It is the space where you can put your finger between two gear teeth. It is indicated by symbol AK. Addendum. The addendum is the distance from the pitch circle to the top of the gear tooth in radial direction. It is indicated by symbol HA. Dedendum. The dedendum is the distance from the pitch circle to the bottom of the tooth in radial direction. It is indicated by symbol HF. Addendum circle. The addendum circle of a gear is an imaginary circle drawn through the tops of the gear teeth. It's the circle that touches the highest point of each gear tooth. The diameter of addendum circle is indicated by symbol DA. Dedendum circle. The dedendum circle of a gear is an imaginary circle that corresponds to the bottoms of the gear teeth. It's the circle that touches the lowest point of each gear tooth. It is also called as root circle. The diameter of root circle is called as root diameter. It is indicated by symbol DF. Both the addendum circle and dedendum circle are important design elements in gears, helping to ensure effective and smooth operation when gears come together to transmit motion and power. Total depth, or hole depth, or tooth depth. It is the distance from the top land of tooth to the bottom of the tooth. It is also defined as the distance between the addendum circle and dedendum circle, measured along the radial direction. It is the sum of both the addendum and dedendum of the gear tooth. It is indicated by symbol H. Clearance. When two gears are in mesh, the radial distance between top of the tooth of one gear and the bottom of the tooth of another gear is called as clearance. It is indicated by symbol C. Backlash. Backlash in gears refers to the slight gap or looseness between the teeth of two interlocking gears. This gap is intentional and allows the gears to rotate smoothly without getting jammed or causing excessive friction. If you have any doubts about the explanations provided in this video, please let us know in the comment section below. In next part, we will discuss about the various types of gears, gear train, gear ratio, and more gear terms. If you find our content valuable and enjoyable, share it with your friends and classmates. If there is a specific complex engineering topic you would like us to cover using simple animations, let us know in the comments below. Your feedback is valuable to us, it helps us create content, and we are committed to making our explanations as clear and detailed as possible. We can't wait to continue inspiring and educating you with our future videos. Stay connected for more exciting engineering content coming your way. Thank you for being a part of our journey.